So this is what the next part is about here. So if we take a look at the function and its derivative, we want to match these functions with this derivative. So what exactly are we looking for? What are the pieces? What's the behaviors that we're looking for? What are the cues that we're looking for? Okay, so the cues that we're going to look for are basically these ones here. We're going to start with these three anyways. We're going to first of all look for horizontal tangent. So let's start with one of the more complicated ones here. So we're going to start with this one right here. Okay. So what we can do with this function is, well, if I can find the horizontal tangent parts here, here, and here, okay, I know that those are slope 0, y prime equals 0. So what that means is, at those x coordinates, I should expect the derivative to go through the x-axis, or the derivative equal to 0. So looking at these, in fact, this one should have 3 points where it crosses 0. So if I look here, there's only 1 here, well, it's kind of 2 here, none here. This one has 1, 2, 3. And not only that, notice where they cross 0. They cross 0 at 2, well, that's where my slope 0 happens. Slope 0 happens at 0, yeah, it crosses 0 here. Slope 0 happens at positive 2, yeah, that's right there. Okay, at positive 2, those 3 points give me 0 slopes. The derivative is telling me the slope is 0, because the y value on the derivative is the slope value. So those are slope values of 0. Yeah, I've got slope values of 0. So that's one thing to look for. The other thing is to look at where the slopes are positive. So if I look at this graph, there is positive slope here. And notice that here we have positive y coordinates. Well, positive slope means positive derivative. That means my y coordinate should be positive. In here, I have negative slope. It's pointing down. All through here, my slope, y values of my slope are negative. That means the slope is negative. That matches. Over here, I have positive slope. Okay, there's my positive slope. Through this section, there's my pen here. Through this section, yeah, all that section that had positive slope gave me positive y coordinates. And lastly, it's pointing down all the way through here. Okay, all those x coordinates are going to point down. Well, notice that all those x coordinates are giving me negative y values, or negative sloping down derivatives. Okay, so these two graphs definitely connect. That's the original function here. The derivative of that graph is here. Okay, so those are the 3 main points that we want to look at. And this is how we're going to determine whether a function is derivative match. The other thing we can think of, this is kind of an extra thing, we've talked about this before, is the changes of a 4th degree function tend to be 3rd degree, or the slopes function of the 4th degree function tends to be a cubic function. Well, that holds true here as well. So that's one other thing that you might want to add. Okay, so let's take a look at the quadratic then. Okay, so there's my quadratic function. My quadratic function has slope 0 right there at -1. Okay, so I'm going to look for graphs that cross at -1. Kind of almost there. That looks like it's -1 here. Okay, none of my other graphs seem to cross at -1. Okay, so I'm going to check my positive and negative slopes. Well, I have positive slope on this side. It's going up. Yeah, I have positive y values on this side here. That seems consistent. This is pointing down on this side of my 0 slope. Yeah, this is all negative y coordinates, which means indicates negative slope. Those two graphs definitely match. The other part of this is consistent, is that the slope of a quadratic function, the slope function of a quadratic, tends to be linear, or it is linear. Okay, so the changes of a quadratic were linear. The change function, or the slope function, is linear. We can look at these constant ones. Okay, we know that this one here is constantly pointing up. Okay, and the slope doesn't change. We have one consistent slope and it's positive. Well, here is one slope. The y values don't change and it's positive. These ones match. Okay, those two go together. We can then make the same analysis with the negative pointing slope. This one is pointing down. Okay, that has negative slope. And it doesn't change. There is a y coordinate that doesn't change, and it's negative. Yeah, that's the correct slope. Okay, so that's got negative slope here. This one was positive here. That was a positive y value here. And lastly, if we take a look at the last one here, well, we kind of have a long zero slope here. Yeah, we kind of have a little bit longer zero. This kind of slides through the zero here. We've got another horizontal tangent here that matches that. Again, we can check our positive and negative slopes. Sloping up here and here. We have positive y here. We know it's sloping down through here. Okay, we know it looks like through that same x coordinates we have negative y values or negative slope values there. So these are the main idea then is we can connect these graphs. So this one connects to that one, and I forget which other ones was. This one, these two go together here. Okay, here and here. So we can look at these three criteria which kind of help us out. These are really kind of main ones. We can try to add another one here too. We can basically say that if we have n as our polynomial power, so this is our f of x equals n, we can say that the derivative function tends to be a power less. Okay, just in general, we'll be a bit more specific with this later, but in general we can look at this idea that, yeah, the degree of the polynomial tends to be one lower for the derivative compared to the original function. So this here, derivative matching, just give it a try. It gives you some sense, it lets you play around with it, tells you if you're right or wrong, but lets you start getting a sense of the shapes and what you should be looking for when you're looking at connecting a derivative and the function together to each other.